Last episode, I used two different models, Noah Micro, Claude Haiku. One hallucinated confidently, the other knew when to stop. And some of you probably thought, okay, but why are there two? Actually, why are there dozens? Like Haiku, Sonnet, Opus, Micro, Light, Pro, Mini, Small, Large. What do these names even mean and how do I pick one? Let's dive in. Same recipe from episode 1, same question. Let's start with the smallest model. 18 seconds. Look at what came back. A clean table, time column, a task column, start by 4, done by 7, vegan adaptation with specific substitutes, great, and a gluten-free note that basically says this recipe is already gluten-free, just check your spice brands. Practical, useful, done. If I just need a quick answer, I'm going to double check it anyway, but this works. Now I ran the same prompt through the largest model available. Same recipe, same question. It took 44 seconds, so I'm not going to make you wait for it. But let's look at what came back. Look at the difference. It added a whole strategy for the vegan guest section, explaining why you should make a parallel pot instead of adapting the main dish. Nice. It gave me a timeline starting from the night before. Separated preparation into phases, told me to keep the rice pots separate so nothing touches the vegan side. Scaling math going for 4 to 6, great. More thorough, more considered. However, did I need all of this? For a Saturday dinner? Maybe not. But let's hold that thought. Now, there are models in between these two. There are medium-sized models as well. They exist in every family, but I'll tell you when to reach for them a bit later. This contrast, though, between the small and the large is where our lesson lives for today. Let's take a simple example, okay? My son is 2 years old. If I ask him what he wants for dinner, he's just going to say pasta and done. 2 seconds, no deliberation. But if you ask me what to make for dinner, I'm thinking, okay, what's in the fridge? What did we have yesterday? Does he need more protein today? Is it too late to start something that takes maybe 30-40 minutes? Or should I just batch cook for tomorrow? 10 variables, 5 minutes, better answer, but a bit slower. Models work the same way. A model size is roughly how many parameters it has. Think of parameters as the variables it can hold inside its head when it's making that decision. So the more variables you have, the more nuance, more ability to handle complex tasks. Fewer variables means faster and cheaper, but less sophisticated. So my son doesn't really need 10 variables to pick dinner. He just needs to decide. So he's fast. And honestly, for a lot of tasks, that's all you need for a model too. A fast answer, maybe not a perfect one. So training a bigger model costs more. Running a bigger model costs more per question. And it's slower because there are many more variables to weigh with every single response. So why not always just use the biggest one? 2 reasons. First, cost. If you're building something that handles thousands of requests, the difference between a small model and a large model is the difference between a reasonable bill and a terrifying one. Second, this is something that a lot of people miss. Bigger is not always better. For simple tasks, a big model can actually overthink it. It can give you more than you asked for. Take longer to say something that a small model maybe says in 2 seconds. The model family you see, Haiku, Sonnet, Opus or Micro, Light, Pro, they are just size tiers from the same provider. Same architecture, just different capacity. It's like buying a car in compact sedans SUV. Same manufacturer, but different trade-offs. You maybe don't want to take your SUV out to just grab some milk from the store, or you don't want to take a compact on a cross-country road trip with 3 kids. Okay, let's talk money. Before I show you the price difference, I need to explain how pricing works. Because models don't charge by the question, they charge by something called as tokens. Now, what is a token? In a simple language, if I have to say, it is a chunk of text. Not quite a word, it's not quite a letter, it's roughly, let's say, 3/4 of a word. Let me show you what that actually looks like. This is a free tool, like many other tools on the internet that you can look for. This I'm using Tick Tokenizer. I'll add the link in the description so you can play with it as you want. Okay, you paste a text in, it will show you how the model breaks it into different tokens. So let's say we are saying adapt this recipe for a gluten-free vegan. 7 words for you and me, but 9 tokens for a model. Some words might get split, some punctuation might become its own token. You don't need to really memorize this, just know token count and word count are not the same. So a full page of text could be around 400 tokens, and a million tokens could be a 750,000 word book. And here's the thing, you get charged twice. Once for the tokens you send in, your question, the PDF that you're sending, your input prompt text, and once for the tokens the model sends back, its answers. So input tokens and the output tokens. They are both priced separately, and the output is always more expensive because that's where the model is actually doing the work. So let's look at some real numbers. This is Amazon Bedrock's pricing as of right now when I'm publishing this video. You can see that for Claude in US East 1 region, the small model Haiku costs about $1 per million tokens in input, $5 per million output tokens. The medium model Sonnet costs $3 in, $5 out, and the large model Opus costs $5 in and $25 out. That's 5 times more expensive from small to large. Same question, same answer, 5 times the price on both the sides. Now, if you're just asking one question yourself, who cares? The price could actually be a difference in few cents, right? Or fractions of cents. But if you're building an app that is handling 10,000 requests a day, each one generating a few hundred output tokens, that 5x multiplier turns into real money fast. So remember, the best model is the model you can afford to run at the scale you need. Let me show you where the big model actually did worse, or at least did more than it should have. Look at this. Opus gave me a timeline starting from the night before. Marinate chicken in yogurt and spices overnight is best. Great. It told me to fry the vegan portion first in clean oil, then fry the chicken onions in separate oil, keep the rice pods separate. It even gave me an oven method and a stovetop method as an alternative. Haiku, simple table, 4 p.m. start, marinating, fry onions into the oven, 7 p.m. done. Great. Opus is doing project management for my Saturday dinner. And here's the real cost of that overthinking. Haiku, 18 seconds, about 1900 output tokens, whereas Opus, 44 seconds, 2700 output tokens. 40% more output, 2.4x slower. That's about 10% more expensive for that one same single request. For a Saturday dinner, it might be an overkill. And if I were building an app that answers the recipe questions for thousands of users, I'd be paying for that extra thinking on every single request. So this is the trade-off. Bigger models are smarter, but smarter isn't always what you need. Sometimes you need fast, cheap, and good enough. Here's how I think about it. First, the biggest factor, cost. We just saw a sample where there's 5 times the difference between small and large on the output tokens. And that's per token, right? When the big model also generates 40% more tokens per response, it definitely compounds fast. That alone narrows the field for most people. If you're building something, cost is the thing that decides what's even on the table. If you can't afford to run it at scale you need, it doesn't matter how good it is. So start there. What can you actually sustain? Then, once cost has set your boundaries, 3 questions can help pick within them. 1. How complex is the task? Summarizing an email, small model. Writing a legal brief, big model. Adapting a recipe, maybe a medium model. 2. How many times will you run it? If it's one question for you personally, use whatever you want. If it's an app serving thousands of users, speed matters just as much as quality. Start small, upgrade only when the quality isn't good enough. 3. What are the stakes? If a wrong answer ruins dinner, that's low stakes. But if a wrong answer means bad financial processing logic that costs you millions, that's high stakes. Higher the stakes, bigger model, plus you have to add verification on the top. That's it. Cost sets the ceiling, complexity, volume, and stakes help you pick the floor. You don't need to memorize model names, you need to know what you are optimizing for. One more thing, I've been showing you models from different providers like Claude, Noah, Llama. How do you pick a family? Pick the one that's available where you are already working, right? Like if you're on AWS, you have access to all of them through Bedrock. If you're somewhere else, use what's available there. The concepts are going to be the same. If you are just getting started, remember, models come in different sizes. Bigger is smarter, but slower and more expensive. For everyday tasks, a medium model is a sweet spot. Try a few, see which one feels right for what you're doing. If you're building something, start with the smallest model that gives acceptable quality. Only upgrade when you can point to a specific failure that the bigger model can actually fix. Don't start big and optimize down. Start small and justify up. The decision framework is complexity, volume, stakes. And remember, you can use different models for different parts of your system. So a router doesn't need to be the same size as the reasoner. So the model that decides, let's say, which tool to call doesn't have to be the same one that is actually processing or doing some kind of thinking for you. So next time, we are going to talk about why model forgets what you told it. Right along.